Thank you, Paul, and thank every one of you who's come to this talk. It's a pleasure to be here and to talk about all of this. So my interest is in machine learning methods, and I think that it's fairly well accepted these days that they're very much a part of our toolkit as statisticians, and we really can't do without them because of the much higher predictive accuracy and flexibility of these models. Machine learning methods are distinguished by highly computational algorithms, and the emphasis is on prediction as opposed to traditional statistical inference, such as p-values. Regularization procedures, which fall under this machine learning envelope, include lasso and LARS and elastic net, and they're all implemented in SAS regression procedures such as GLM select and HP gen select. For classification and nonlinear regression, there are SAS procedures for generalized additive models, for decision trees, random forest, gradient boosting, support vector machines, artificial neural networks, you name it. It's available in SAS. So beyond the actual procedures themselves, SAS offers a number of different environments in which you can actually perform these kinds of analyses. So we can do traditional SAS programming. Data steps, PROC steps, and looking at results. There is SAS Enterprise Miner, which is a large focus of my talk today, and SAS Fire. So in this talk, I'm going to focus on the first two of these environments, really to demonstrate how you can do similar things in both environments, but also to perhaps point out some of the advantages of SAS Enterprise Miner. This talk is not an introduction to machine learning methods, so I'm not going to spend any time explaining what support vector machines are, what random forests is, or decision trees. This is about comparing the environments for applying these kinds of technologies. So my first example here is a data set which has a little over 10,000 observations. It's auto insurance claim data from Germany. There are two natural response variables in this data set. One is the amount of the claim. There are a lot of non-claims here, so there are a lot of zeros. And then claim end is just an indicator variable for whether or not an insurance claim was made. So about 3/4 of the data have got the value 0 on this claim end, and about 1/4 of the data has ones. There are 20 predictor variables available, including the distance to work, types of job, family income, age of the vehicle insured, the type of vehicle, the value of the vehicle, house value, number of children driving, and some variables relating to driving record. So what kind of analysis would we do? Well, I think if I'm just sitting down to do this as a first start, this might be a list of things that I would consider doing. First, summarizing some of the variables in the data set, the interval valued variables, do some transformations as needed, impute some missing values if there are lots of missing values in the data set. If there aren't, it's no big deal. We just drop those observations from consideration, but if there are hundreds and perhaps thousands of missing values, then we might consider imputation. I'd like to be able to compare different methods, and so I want to partition the data set into a training data set piece and a test data set piece. And then finally, we can do some predictive analytics, and perhaps three that one might think of right off the top of one's head: logistic regression, decision trees, and random forests for the claim indicator variable. So here are some summary plots generated using PROC univariate for a couple of the variables here, and you can see that both the income and the claim amount are skewed to the right, and so typically we would choose to transform those variables, whether they're a response variable or even a predictor variable. Very skewed predictor variables can be highly influential. And so I did. I took logs. I took logs of the claim amount, the income, and the house value. You notice that there's an offset of 1 there. That's because some of these variables have got zeros in them. And if you take a log of 0, you're going to get a missing value. The next step is to do some imputation, because there are a fair number of missing values there. And so the SAS procedure I might use to do that is PROC HPIMPUTE. And so a very simple kind of imputation for numerical variables is simply to replace the missing values with the mean of that variable. And so that's what method is equal to mean does here. The ID variable, so by default, PROC HPIMPUTE will just take all the variables that you've imputed into the new data set. And of course, I want all the other variables too. And so that's accomplished using an ID statement. And here's a summary of the results that one gets from that imputation process. You can see that there's a column there which tells us that we used the mean for all of these variables, and then it tells us the new names of the imputed variables and the values, since the mean was used for the imputation. So the next piece is to partition the data set into test and training pieces. And so I use HPSAMPLE to accomplish that. And you can see that the partition option is identified here. The SAMP PCT is equal to 33 is saying that I want 2/3 of the sample into one data set and 1/3 into the other data set. And then in the class and the var statements, I have the list of variables. Now, what this does is it generates a variable which is called _part_ind_, which takes on the value 0 for about 2/3 of the data and 1 for about 1/3. And so if I want to create separate data sets, then I have to split them out just using a very simple data set step. Okay, so done the preliminaries. We've summarized some variables. I know I'm going through this very quickly because I want to get to something at the end. And we've partitioned the data set. We've done some transformations, and now we're going to apply some analytical methods. And one of the things that most of us think about first when we're carrying out an analysis of a binary response variable is just to throw logistic regression at it. And so I've done that here. I've done the logistic regression both with and without variable selection. The code here is for with selection, and you can see selection is equal to B for backward, and significance level to stay of 0.01. The C-table statement down here provides us with the classifications, the confusion matrix for a given cutoff, and I've chosen 2 cutoffs here, 0.3 and 0.5, and the reason for choosing 2 rather than just the traditional 0.5 should become apparent in a few minutes. Finally, the score statement is used for scoring a new data set. In this case, we're going to fit the logistic regression on the training data, and then we're going to evaluate it using the test data, and so that means we have to score the test data. So here are some of the results that we got. So variable selection, % correct is the overall accuracy, if you will, and you can see that the difference between variable selection and no variable selection is absolutely minimal. It's only 0.2 of 1%. There are only 6 variables removed here, but that's still a significant reduction. If you use a cutoff of 0.5, you will see that the specificity, which is the percentage of zeros that are correctly classified, is 92%, and the sensitivity is a rather terrible 38%. So part of the reason that I chose to do the 0.3 cutoff is that you will see that even though the overall accuracy is slightly less at 73% for cross-validation, that the sensitivity and the specificity are both, in the 70s and quite reasonable values. So in many respects, logistic regression is our baseline. And so what we now do is apply different and in some cases more sophisticated machine learning procedures. And we see if it makes a difference. We see if we can squeeze any more information from the data by using machine learning methods. So I've used decision trees here, a classification tree. And I want to evaluate the accuracy and determine the size of the tree using cross-validation. So that's what's circled here is CV method is equal to random 10, says do 10-fold cross-validation. And by setting the seed, I can always retrieve exactly the same results. The only plot I want here is one which gives me the accuracy of the predictive accuracy of the classification trees as a function of the tree size. And there it is. And I'm not sure how clear it is up there. It's a little bit tiny on my screen here. But it looks like the misclassification rate is minimized with a tree with 32 leaves. That's actually a pretty big tree in the grand scheme of things. Breiman and Friedman and the other authors who developed classification trees suggested something called the 1SE rule. And the 1SE line is the line across the plot. And the 1SE rule would pick a very small tree with just 4 leaves or terminal nodes. And so I thought, well, why not try several? This is one of the nice things about modern computing environments is you can just try multiple things and you see what turns out to be best. And so for future analyses, I did 4, 14, and 32 leaves. So the way that I specify the number of leaves in the code is using this prune cost complexity, leaves is equal to 14. So that one's saying build the decision tree with 14 leaves or terminal nodes. And then this whole pile of stuff down at the bottom, for scoring a new data set within HPSPLIT, what we have to do is output all of the code for the commands for prediction for the tree, and then we re-import them within a data step to carry out the prediction. And so here are the results from applying decision trees. And so just to remind you, on the test data for logistic regression, we had about 77.5% accuracy, 77.8% accuracy if we did variable selection. And then the 3 trees, so the tree with only 4 nodes has got a slightly less, a lower predictive accuracy of only about 75.5% on the test data set. Now you might say, well, that's quite a bit less than the logistic regression, and so we should probably just discard this out of hand. But I would argue that it depends upon what your objectives are in doing the analysis. A decision tree with only 4 leaves, 4 terminal nodes, is a very easy thing to interpret and a very easy thing to explain to almost anybody. And so I actually was pleasantly surprised at that accuracy. As you add more leaves, you can see that the overall predictive accuracy is inching up towards what we got for the logistic regression. So these results are fairly common, fairly standard for what I'm used to seeing, that decision trees are really not that much more accurate than logistic regression. Often the accuracies are about the same. But random forest is a different kettle of fish. In many problems in which I've applied it, and I think you heard this last night in the opening session, random forest can sometimes smoke the competition. And you can really get much more precise or much more accurate predictions, and you can learn a lot. So this is one of my favorite procedures within SAS and other environments too. Essentially, as the name suggests, a random forest is a lot of trees. And I chose to set the number to be 200. The default here in PROC HPFOREST is actually 100. So here's an option which you probably don't remember 100% of the time. Score prol is equal to oob. So this is the kind of thing when you're working with traditional SAS programming, there are lots of options that you're going to have to use at various times, and you've got to remember them or you've got to look them up. These are the only two options. And score prol is equal to oob is the one that I look up every time because I can never remember exactly what it is. Okay, the target is claim index, and I specify the level to be nominal. The two input statements, you can see one is for the categorical variables, and so that's got level as nominal, and one is for the interval valued variables, and so that has level is equal to interval. So, going down to the very bottom there, you see random forests out of bag, which is sort of roughly comparable to cross-validated for other techniques. And you see that the overall predictive accuracy is 77%, and that's really not too much different, in fact, slightly less than the best logistic regressions. So this is a problem where using a much more sophisticated technique did not actually yield significantly better results. So now I want to repeat this analysis in SAS Enterprise Miner and then perhaps draw some conclusions. And so in my very first step here in this picture, I'm just simply establishing a project. And so this is SAS GF Insurance Claims Analyses. And then the next step that I have to do is to create a library. And so that involved finding a pathway to where the data sets actually are. And that's what's in this little dialog box. I just copied and pasted that from SAS Studio. My third step is that I want to create a new diagram for my analyses because SAS Enterprise Miner has got a graphical user interface and that's how it works. So I'm going to call it Analyses of Claim End. The next step that I have done is to create data sources or a data source for the data step, and there's a wizard for doing that. So you just go File, New Data Source, and then there's a wizard and you just follow it. And I've had to make a little change as I've gone through here. So if we look at this variable coming across here, claim end, is that it? Can't see it from there. Yeah, claim end. So claim end is our target variable. And so I actually have to specify that that's going to be a target variable for subsequent analyses. I could be doing a regression here, so I could be using claim amount. And so I'll also specify that that's going to be a target variable. Target being the SAS Enterprise Miner name for response variable. So the next thing that I want is to do some variable summaries, and I've used the Multiplot node. I just drag it and drop it into the workspace here. And a couple of the graphs which came out of that are a histogram for age and a histogram for income. As we saw with PROC univariate, income is skewed. The distribution of income is skewed, and you can see that from the histogram. For the age variable, I don't know. My students would accuse me of making up this data, right? I mean, that looks too normal to be believed. All right, I've done that. So now I want to transform some variables. And so again, I pull down another node and transform variables node. And I switch off the automatic transformations because that will transform all the variables which happen to be interval valued. And I actually only want to transform the ones which are skewed. And so then I pull up, using the variables, a little dialog box here that you can see, and I choose the variables that I want to apply a log transformation to. And this is the output. And without me actually having to explicitly say it, you can see that the transformation that SAS Enterprise Miner applied here was the log of claim amount, for example, +1. So it automatically puts in that offset of 1, which I think is a desirable thing to do. So I think that's actually a valuable thing that's just been put in. Okay, the next thing is to impute the variables, impute some of the missing values. And I use an Impute node here. And I've selected some variables. And in the pull-down box that you can see up there, I have chosen the mean. So that's exactly the same as I did using PROC HPIMPUTE. Okay, so now we're into the analysis stage. And so I'm going to first try and do logistic regression. And you do that by going into the model menu and choosing the regression node. And then down here, initially for the first one, I did no variable selection, exactly as I did in traditional SAS. And then here, I'm actually doing some variable selection. And so I'm switching some bits on and off within the dialog box to make that happen. So what I have done here, the options that I have chosen here, will do backward elimination using the same p-value approach that you get in PROC Logistic. Okay. So next up is to fit decision trees. And the way that we control the decision tree size is using the depth. And so, for example, here is some output from a decision tree with of just depth 3, so a very small decision tree. The thing which I find interesting is the very first split in this decision tree gives us quite a lot of information. It's a split on whether the person lives in the country, so in a rural area, or in an urban area. And as you look at those numbers, you can see quite a substantial difference in the rates of claims for auto accidents. And then the next split is on the occupation of the driver. And again, there are fairly substantial differences between the two splits there. Finally, I want to do random forests, or not finally, but random forests is next. So I have to go into the HPDM menu to pull down random forests. One of the neat things about random forests, one of the reasons that I am very much like it, is that with random forests, there's almost nothing to tweak. It's really an off-the-shelf procedure. That was Leo Breiman's intent when he first had the idea was, I want to build a set of tools for statisticians so that they don't have to spend a lot of time tweaking and tuning parameters as we often have to with machine learning methods. And so perhaps the one thing that I did change here is the number of trees that we are going to fit. So given that I've got all of these things, is there anything else I might throw in? Well, turns out that in the HPDM menu, there's an HP tree, and that tree program's much closer to HPSPLIT than the one in the modeling menu. So I've thrown that one in as well. And, oh, you know, I kind of like gradient boosting machines and support vector machines. And to look up this code and to figure out the code and the options and stuff in traditional SAS programming, it's going to take me time, right? Whereas in SAS Enterprise Miner, I just go into a menu and I drag and drop some things in. And then there's a menu where I just have to tweak one or two things, and boom, I am ready to go. So this potentially does a lot of analyses. I haven't showed you any of the output rather. What I'm trying to do is to show how you do a comparison. And this is like, for me as a statistician who's always trying to compare, you know, different methods on the same data set to see what is a better approach, this is like fairy dust. And so there is a model comparison node in the assess menu, and it is absolutely dazzling. So I just hook everything up, join everything up to it, and then I run the model comparison node. So it'll give me ROC curves for all the different methods overlaid on top of one another for both the training and for the test data set in this particular example. And it will also give me some accuracy metrics. Now, it doesn't automatically produce the sensitivity and specificity. You could add, a SAS Code Node and extract those bits of information, but there's still enough here to see what's going on. The 77.5 and the 77.8 have been rounded up to 78%, and you can see that for the logistic regression. On the test data, so we got 79% for the trees, about 74, 75%. It's kind of what we saw before. About 76% for random forest, 77% for gradient boosting, and so on. So actually, this confirms what we saw before. There's nothing that is really better than the logistic regression here. Okay, so some conclusions. Now you see, I'm nowhere near the end of my talk because I want to now skip into a session where I actually show you how to do this live in Enterprise Miner. So SAS, traditional SAS and SAS Enterprise Miner are two analysis environments that facilitate the use of machine learning methods for data analysis. One has a lot of control using PROC, HPIMPUTE, and PROC this and PROC that. There's more control there than there is in SAS Enterprise Miner. On the other hand, SAS Enterprise Miner allows one to apply many statistical analyses methods particularly easily, and then it facilitates the comparison of the accuracy, the predictive accuracy of all of these methods. Now, here's the kicker. Time-wise, SAS Enterprise Miner is very efficient, and time is money. Let's be clear on that. So the calculations that I did in SAS Stat took a morning, so about 4 hours or more, and then some additional time plucking the results for the different methods and putting the accuracies in a table. And the comparable analysis, which I briefly showed you in SAS Enterprise Miner, that took 45 minutes. I mean, really, 45 minutes. And so this is now my new favored way of getting an initial analysis, particularly if I need to get answers quickly. And sometimes our university president yells for information right now. Is SAS Enterprise Miner. I can go in there and I can do a bewildering array of very sophisticated analyses, and I can do it in no time flat. And if I decide that there's one particular group of methods that I want to follow up on, there's nothing to prevent me from coming back and going into traditional SAS or even writing SAS code within SAS Enterprise Miner. Okay, so I thought I would try and show you the how this works live, and I think we've got plenty of time to do that. So I'm doing all of my analyses and calculations in SAS OnDemand, and here's my sign in for that. Signing in. Okay, and I'm going to need just a little nugget of information from SAS Studio. So I'm going to log into SAS Studio. But the main thing that I want to do is to run SAS Enterprise Miner. So click on that. With apologies. Okay, so I want to start a new project. And so I'll just go in and I'll give the project name and I'll call it New Mullen Analyses. First step that I have to do is to set up a library. And so I'm showing you this stuff. I mean, I could have skipped this, but this is part of what you have to do. So I set up a new library. And so I'm going to call that SAS GF. And the path is coming from the SAS Studio. So this is where all of my SAS Enterprise Miner and SAS Studio material is. Now once I've done that, I can select some data sources. And so that's my next step is File, New, Data Source. So SAS table, yep, and browse, and it's in SAS GF, which I've just established. And we'll call it Mullen. Now here I have to do some work because all of the variables are listed as input variables. This very last one is the presence or absence of a species of weed in our national parks. And so I want to change that to target. That's my response variable. And it's not interval valued, it's actually binary. And I want to create a second data set, which I'm going to use for testing the different procedures. So that's also File, New, Data Source. And it's a SAS table, and it's in SAS GF as before. And that is Mullen test. Once again, I'm going to change these variables to target, or this variable to target, and binary. This data set is going to be our test data set. So I have to specify that and finish. That's the setup. That's the startup for all of this. And so finally, I want to create the workspace where I'm going to do the analyses. And so that is a diagram. And so here is my diagram, Mullen analyses. Okay, so pull Mullen onto the workspace. Maybe increase the size a little bit. First thing I want to do with this is to partition it. So I just bring this over here. Come on. And connect it up. And what's the partition I want to use? I think I'll use 75% training and 25% validation and 0 for the test, because that's a separate data set, and then I run. And now I would like to bring in the Mullen test dataset. And I would like to append that so that it's recognized. So I use the append node. You can see, drag and drop. And I just hook these up. And I run. So this is the HPSAMPLE piece, right? And you can see how quickly it goes. So now I've got my data sets and I need to start thinking about some analytical procedures. So I'll go into the model menu and I think we'll pull down a regression. And I'll rename that Logistic reg no var select. Connect it up and run it. Is this hard enough? I mean, this is kind of amazing technology that we have here. To have regression, logistic regression available in this form, well, that's fine. But to have support vector machines, random forests, gradient boosting machines, that's something quite different. And then I could do some variable selection. So I can actually copy and paste a node. And I could go in and again rename it. Take out that. And then I'll come down here and maybe tweak some of the options. So selection method, it says none. Actually, I want to do backward. And it says use user defaults. Yeah. Okay, how am I going to measure the accuracy of it? Then I think I'm going to use the validation misclassification rate. And so, you know, again, we're doing standard machine learning things with almost no effort whatsoever. Another thing I might want to do is gradient boosting. In many applications, I found gradient boosting to be phenomenally accurate. Whoops. And so I'm not really going to play with any of the defaults here. I'll just run gradient boosting and we'll see what we get. I run each one as I do it, but for this, I'm thinking now maybe I should have just put them all down there and then clicked run on the assessment.
It's more important to do them individually when you're using regular SAS code so you can figure out what you did.
Well, that's pretty quick for gradient boosting. I mean, I find gradient boosting can be very slow. And so now we'll go into HPDM, which has got some of the high performance things. And I like random forests, as we've talked about. So again, the thing about random forests is, you just run it off the shelf and give surprisingly good results. But it does take a little while. So soccer conversation? For me in SAS OnDemand, when I'm teaching classes, there's obviously some times of day when everyone else is teaching a class using SAS OnDemand. And so it can take a little while longer than it would on a local computer. Okay, that's run successfully. And now what else could we put in here? We could maybe put in a high performance tree. And I could also put in perhaps a support vector machine. I'll put that down here. Now with the support vector machine, I might change something. The interior point optimization for looking at the kernel, I prefer not to have a linear kernel, so we'll go to, say, a polynomial too. And now, finally, to assess all of these things, I want to do the model comparison node. And I bring that over here. And then my job is just to connect everything up. Can I what?
Can you just draw a box around both of them and connect them at once?
Probably. I'm not that sophisticated a user. So, you know, that's the second sort of message is I'm just not that sophisticated a user of SAS Enterprise Miner. It's relatively new to me. And yet, you know, I can get through fairly sophisticated analysis in, it's going to be about 15 minutes, right? Now, I have spent years of my life studying these data. And to have gotten to this particular point, you know, it took me quite a lot of time in the past. Your battery is running low, okay? That does put an end to the talk, doesn't it? Okay, and I want to see the results before the battery dies. Good. So here are overlaid ROC curves for the different methods. And so, you know, I like my random forests. Those of you who've used random forests may not know this, but if you take your original data, your training data, and you pass it down through the forest, you get 100% accuracy almost every time. Oh, no. Is there a plug up here? Yeah. All right. Yeah, you saw it, but I didn't get to my punchline. Oh, dear. I don't know whether I'll be able to retrieve this quickly enough, but we'll see. Oh, no. Yes, there it is. Okay, so we want to look at the results. And, okay, so we had this. And then the proof of the pudding, though, is really in looking at accuracies. And so one of the things that I'd like to take you down to is looking at the test data set here. And I know this is kind of small, but here's the ROC index for the different methods. And, you know, there's not a lot of differences down there, but I come down to the misclassification rate down here. And I see that for random forests, it's about 16%. And then for these other methods, 0.26 and 0.27, 0.25, 0.24. Okay, so that's a 50% increase in the misclassification rate. Okay, so this is an example where forest actually does smoke just about everything there. I would put it to you that that difference of 8 or 9 or 10% is almost always going to be meaningful. And that's what we observe here. Okay, so apologies for the computer dying. That concludes my talk, so if you have any questions, I'd be happy to answer them.
I do have a question.
Yeah.
Do I need a microphone?
They want you to use a microphone, I think. There's one just behind you.
My question is, if you had a rare event,
Yep.
what settings would you change?
There are different kinds of analyses that I might carry out. So in using SAS Enterprise Miner extensively this last year, what I discovered is that for cases where you have very extreme differences between presences and absences, so fraud detection is an example of that, where you might have 100,000 observations of which 200 are cases of fraud. Then there are different techniques which are available in SAS Enterprise Miner for dealing with that. So one of the clever ideas is to build an initial tree, and then if you have a gigantic node which is absolutely pure on the not fraud, then you just remove those observations and you keep peeling off observations until you get down to a data set which has got, you know, similar numbers of each of them. In terms of the settings in the things that I've done there, there's probably not much that I would actually tweak. What I would do is extract the predicted values and then do some manipulations on those.
Thank you.
Other questions? Okay, thank you very much.